Okay, so this section is about how to find the derivative of polynomial and exponential functions. As we have seen in in a previous section, to find the derivative of the polynomial x squared, we had to follow all these steps. What today we're going to see is that there is an easier way to find that, rather than finding the limit of that ratio that there's a faster way of doing it. So this is a very exciting section. I'm going to go over the slides as I did before. So the first one talks about the derivative of a constant function. So at every single point here, whether I have 1c, 2c, 3c, and so on, or any point on this line, the tangent line happens to be itself. So that's why the slope of every single tangent line for every point on this line happens to be the line itself. Now, this slope in particular happens to be 0 because it's a horizontal line. So therefore, no matter what the x is, f prime of x for a function like that is 0. So let's give a couple of examples. If I have f of x equals, 3.5, so I know that's a constant function, and if I want to graph it, I can at 3.5 maybe is this. So I have a constant function like that. Therefore, what I need to do is I need to find the slope of the tangent line here. The tangent line is going to be itself, and the slope of that line will be 0. So f prime of x in here is 0, no matter what the x is. If I ask you for the derivative at 4, what's the derivative at 4? 0. What's the derivative at 5? 0. What is the derivative at pi? 0. What is the derivative at 100,000? Still 0. If I'm talking about the function y equals -5, that would be a function that looks like this. So what is f prime of -10? Well, -10 is over here, the point is over here, the tangent line again is itself, so that still will be 0. Okay, so if this is the function f prime of x, no matter what the x is 0. Just for fun, what would be f double prime of x? Well, what's the derivative of 0? Still 0. What would be the third derivative of that? You guessed it right, it's again 0. So for any higher derivatives that I'm taking, it will be 0 all along. For those who don't believe me, this is the proof that shows that for a constant function, the derivative is 0. You can follow step by step. It makes a lot of sense. This is another way of writing the same. The derivative of a function that is just a single number respect to x is 0. Now this is a very useful notation, because if I ask you what is the derivative of 6 respect to x, notice how the 6 doesn't have an x in it. So this talks about the function f of x equals 6 or y equals 6. So the way that you see it in here, the inside is the function. It is not anymore that value that you are evaluating, so please do not get confused with that. This is not f of 6. This is the function y equals 6. So because this function is a constant, does not depend on x, therefore the derivative is 0. Okay. If I'm taking the derivative of something that looks like 3x squared respect to x, then this will not be 0. Sorry, this will not be 0, and this will be something else. Notice how the function does depend on x, so the derivative will be something that is related to x. In here, the function has nothing to do with x, therefore it's a constant, so the derivative is 0. Now let's talk about the power functions, because using the power functions, we're going to determine how to take the derivative of a polynomial. And remember, a polynomial is the sum of a bunch of powers of x. So let's say that I have the power function x to the some number, as long as that number is a positive integer. So I'm talking about x squared, x cubed, x to the fourth, and so on. So for y equals x, that's why it says when n is 1, for y equals x, the slope of this line is 1. Therefore, the derivative will be 1. Because you know that for every point, the tangent line will overlap with the line itself. So the slope of the line is the slope of the tangent line. So f prime for the x, no matter what the x is always 1. So if f of x is x, the derivative is 1. So the derivative of a function that is just x, remember that this implies f of x is x, respect to x is 1. Okay, remember if the function is x, f prime would be 1. So this is another way of writing it. Remember when we took the derivative of the function y equals x squared. I need to remind you this was seen in another video. We did all this work and we found out that f prime of x is 2x. Right there, you see it. Okay, so the derivative of the function y equals x squared respect to x is 2x. The derivative respect to x of x cubed is 3x squared. Do you see a pattern going on here? What would be the derivative of x to the 4th respect to x? So let's look at this one. X cubed, when I take the derivative, becomes x squared. Remember that I'm going down 1 degree whenever I take the derivative. But the exponent now becomes a coefficient. So if I'm taking the derivative of x to the 4th power, the 4 will become a coefficient, and then x is going to be reduced. The power of x is going to be reduced by 1. Okay? And I can continue doing the same pattern on and on. I can take the derivative now of x to the 25th power respect to x. So the 25 becomes a coefficient, and then x is raised to a power that is 1 less than 25, which in this case will be 24. So in general, I can take the derivative of x to any power by following this rule. The power will become the coefficient, and then the new exponent will be 1 less than the current exponent that you have, as long as n is a positive integer. It does not work when n is a negative number. Remember that polynomials are going to be all the sum of powers of x as long as those powers are positive or 0, but no negative ones. It turns out that this power rule can be generalized not for only positive integers, but also for any real number. But just keep in mind that this rule, although it does apply for any number that x is raised to, it will not be a polynomial anymore. For example, if I have the function y equals x to the negative 1, remember that that's just the same as having y equals 1 over x. This is a reciprocal function and not a polynomial, because the exponent of the x is a negative number. So this is a function that is a reciprocal function, or a rational function more generally speaking, but still, if I'm trying to find the derivative of this, I still can do it by using this useful rule. So what would be f prime of x if f of x is x to the negative 1? Remember, the exponent becomes the new coefficient, and then the new power of x is 1 less than the current power. So 1 less than negative 1 would be negative 2. So f prime of x is negative x to the negative 2, or you can see it as f prime of x equals negative. Remember, a negative exponent is simply the reciprocal of that. So if we were having a quiz or a test, multiple choice or AP multiple choice, you may see either notation, and both of them are just the same. It is just rewriting this expression with positive exponents only. But the rule still applies. Remember that 1 less than negative 1 is not 0, and it's negative 2. What this rule is telling us to do is that since we know the derivative of a function and I multiply it by any constant. This is just the constant multiplying the derivative of such function. So let me give you an example on the side about this. Let's say that I have the function 6x to the third power. Okay, so I know the derivative of x to the third power respect to x is 3x squared, as I have seen before. Remember, the exponent becomes the coefficient, and then the new exponent is one less than the previous one. So how can I use this information to find the derivative of this new function? What would be f prime of x? Well, f prime of x will be 6 times the derivative of x cubed respect to x, and that just makes me replace this with this expression. So this would be 6 times 3x squared, so now it would be 18x squared. So the derivative of 6x cubed becomes 18x squared. So that's how I can multiply a function by the derivative of something that I already know. If the function was 2x to the fourth power minus 4x to the third power, in this case this is a polynomial, I know what the derivative of x to the fourth is. I know the derivative of x to the third also. This one is getting multiplied by 2. This one is getting multiplied by -4. So f prime will be 2 times the derivative of x to the fourth, which is 4x to the third power, minus 4 times the derivative of x to the third power, which is 3x squared. So now when I simplify, I simply get 8x cubed minus 12x squared. And I don't have to calculate the limit as h approaches 0 of all that funny stuff that we had before.